Good afternoon. I would like to present the report on topic minimizing security risks and improving system reliability in blockchain applications, a testing method analysis. Authors are Iryna, Kyrychenko, Olha, Shyshlo, and Nadiya Shanidze from Kharkiv National University of Radioelectronics. There are many systems that process and save customer personal information. Every client would like to be sure that their personal data will be transmitted, processed, and stored confidentially, securely, and credibly. To solve this problem, many systems use certain encryption algorithms or technologies to ensure the integrity, reliability, and confidentiality of transmitted or received data. Today, the most popular of these is blockchain technology. One of the most important stages of system development is testing, and systems using blockchain technology are no exception. An important step in the testing process of any system is the development of testing strategy. The main goals of the research are to determine the impact of the testing methods on security and reliability of the blockchain-based systems, and to minimize security risks and improving system reliability in the blockchain applications. Blockchain technology has its own advantages. Immutability. Blockchain supports immutability, meaning that it's impossible to erase or replace already recorded data. Therefore, blockchain prevents data falsification in the network. Transparency. Blockchain is decentralized, which means that any participant in the network can verify their data. Therefore, the public can trust this network. Censorship. Blockchain technology is free from censorship because it's not controlled by any side. That is why no authority, including governments, can interrupt the work of the network. Traceability. Blockchain creates an irreversible, auditable trail that allows to easily track changes in the network. To ensure the security and reliability of system based on blockchain technology, it's necessary to pay special attention to the following methods during the testing process: functional, security, and penetration testing. Functional testing is one of the most basic and fundamental testing methods for many systems. Adapting this method to system based on blockchain technology, the following checks can be identified within this method. Checking the block and chain size. This check should focus on what transaction data should be selected, what encryption method should be used to connect these blocks, and similar complex scenarios. Checking the ability to transfer data. This test should cover both the successful transmission of data and data loss during transmission between blocks. Data loss should also be tested as underlying blockchain architecture is based on transactions and data security. Checking the ability to add blocks. Blocks that are added to the chain should be carefully evaluated because they cannot be changed after adding them to the chain. Checking the smart contracts. Ensuring that the parties that are involved in a transaction adhere to the rules of the smart contracts will ensure the smooth functioning of the blockchain application. These are the key points that make it possible to confirm the correct functionality of blockchain application. The next method that should be included in the test strategy is penetration testing. Cyberattacks and fraudulent hacking attacks are extremely difficult to perform in blockchain-based systems when smart contracts are working correctly. However, any mistake in the complex mathematical and programmatical rules can be a good opportunity for an unauthorized user with malicious intentions. Blockchain penetration testing allows QA engineers to create and execute test cases that simulate the behavior of cyberattacks to see if the action of any unauthorized user in the system will be blocked. This method involves testing that simulates real-world scenarios by attempting to log insert network services, wireless networks, social engineering networks, and blockchain applications. Security testing is also one of the most important testing methods. In this stage, QA should check whether the blockchain application is fully protected from attacks including viruses and malware. Any outgoing transaction or data transfer cannot be stopped, so QA must identify potential threats through security testing. Also, at this stage, you should make sure that the blockchain system prevents the processing of faulty or damaged data before it becomes a risk for the user. Each bug has its own weight, which depends on many factors. This includes criticality of the bug from a technical point of view and a business logic point of view, time spent on the fix, complexity of the fix from a technical point of view, time spent on checking the fix, complexity of checking the fix, potential risks after the fix, potential risks if the bug was not found, and time of detection. Kennebec wrote in this book that most defects end up costing more than it would have cost to prevent them. Defects are expensive when they occur, both the direct costs of fixing the defects and the indirect costs because of damaged relationships, lost business, and lost development time. To assess each of the coefficients, it's proposed to use a scale from 1 to 5. Therefore, it makes sense to consider the dependence on the impact of system security if the bug is found and fixed at the certain stage of testing. The following bugs were found during unit testing. First bug was found during block size checks as part of the functional testing. Second bug was found during checks of the ability to add blocks as part of the functional testing. And third bug was found during smart contracts checks. The following bugs were found during integration testing. First bug was found during chain size checks as part of the functional testing. Second bug was found during checks of the ability to transfer data as part of the functional testing. And third bug was found during smart contracts checks. The following bugs were found during system testing. First bug was found during checks of the ability to transfer data as part of the functional testing. Second bug was found during smart contracts checks. Third bug was found during checks of the system security as part of the security testing. And fourth bug was found during checks of the system security as part of the penetration testing. The following bugs were found during acceptance testing. First bug was found during checks of the ability to transfer data as part of the functional testing. Second bug was found during smart contracts checks. Third bug was found during checks of the system security and part of the security testing. And first bug was found during checks of the system security and as part of the penetration testing. Correct testing of the system at the unit testing stage can significantly reduce the number and severity of risks, including those to user data security. If a critical bug is not found in this stage, the cost of the error will increase depending on which of the subsequent testing stage it is found. It is also worth noting that error in blocks or blockchains are critical in terms of potential risks. After all, according to blockchain technology, data blocks cannot be changed, and blockchains are built based on previous blocks. Therefore, one mistake can lead to significant problems for the entire system, especially when it comes to data security. Problems with the integration of system components also have a significant impact on the security and reliability of the system. That is why integration testing plays a significant role in the testing process. The cost of the mistake at this stage will also be much lower at one of the subsequent stages. However, the potential risks after a fix are much lower than the potential risks if the bug was not found in this stage. Security and penetration testing should be conducted during system testing to ensure that the system is stable and meet the specified data security requirements. One of the last stages is acceptance testing. In this stage, the cost of the weight of the bug is the highest. After all, the greatest risk both after the fix and if bug that directly affects the security and reliability of the system is not found during acceptance testing. Current table represents the summary data with the average weight and price of bug found at one of the testing stages, as well as for the case when bug related to system security was found in production. Summarizing the results at each stage of the experiment, we can conclude that special attention should be paid to unit and integration testing. After all, it is from this point on the cost of the bug begins to grow exponentially. However, system and acceptance testing also play a significant role in the security of blockchain-based systems. Therefore, to minimize security risks and increase system reliability in blockchain applications, it is necessary to perform functional testing at each stage of testing. Particular attention should be paid to the testing of smart contracts. Security and penetration testing should also be performed as part of the system testing. Summarizing the results of the research, we can conclude that during the planning of the testing process, special attention should be paid to functional testing and testing of smart contracts as part of it, because this testing method can provide confidence in the reliability of the system from the first stages of testing. The results of the research can be used at the planning stages of the testing process, such as creating the test strategy and test plan. Thank you for your attention.